Now let's take a look at solving equations with rational expressions. So here are some hints, the steps that you want to follow. First is you're going to factor your denominators. Secondly, look for your least common denominator. The third step is to multiply both sides of the equation by the least common denominator. And the fourth step is to solve the remaining equations. Remember, if it's a linear equation, you're going to solve it for one variable on one side and get all the numbers on the other side, just like we did at the very beginning of this course. And if it's a quadratic equation, that means it has an x squared in it. That's going to be similar to what we were just solving in the last couple chapters, and that is you set your quadratic equation equal to 0, then you factor, then you use your zero product property, and then you solve. So let's take a look at an example. So I start with x over 3 plus 5 halves equals 1 half. And my least common denominator is 6. So I will multiply both sides of the equation by 6. When I do that, I'm going to use my distributive property. And what I notice is that when I use my distributive property, everything gets multiplied by 6. So if I have 6 times x over 3 plus 6 times 5 over 2 equals 6 times 1 half, well, what I notice here is that the 3 will cancel with the 6 and I'm left with 2. And the 2 cancels with the 6 and I'm left with 3. And the 2 cancels with the 6 and I'm left with 3 there. So I now have here 2 times x, which gives me 2x, 3 times 5, which gives me 15, and 3 times 1, which gives me 3. I now have a linear equation to solve, and my whole purpose in multiplying by the least common denominator was to get rid of the fraction. So I did get rid of the fraction. I solved this by subtracting 15 from both sides, then I divide both sides by 2, and I get x equals 6. I can always check my answer by substituting x equals 6 back into my original equation and solving. So here's another example. I have 3 over x minus 1, which is equal to 3/5. So my least common denominator is 5 times x minus 1. So if I go to solve that, I'm going to multiply both sides of the equation times 5 times x minus 1. And when I do that, the x minus 1's cancel out here, and I'm left with 5 times 3, which is 15. And here the 5's will cancel, so I'm left with 3 times x minus 1, and I can then use my distributive property. Again, I have a linear equation. To solve a linear equation, you get your variable on one side, so I add 3 to both sides, divide both sides by 3, and I get x equals 6. Now, this problem is special because it has a rational expression is equal to another rational expression, and nothing is being added or subtracted to each of these rational expressions. And when I have that, I can use something called the cross multiply and divide. So I can cross multiply this way, so I go 3 times 5, and then I say it's equal, and I cross multiply this way to 3 times x minus 1. Now it's really important that you put parentheses around that x minus 1, otherwise you won't use your distributive property. But then I can solve this. So 3 times 5 is 15, and 3 times x minus 1 becomes 3x minus 3. Solve that just like I did up here, and I get x equals 6. So that is another way that you can solve rational expressions if you don't have anything being added or subtracted to either side. So let's take a look at some more examples, and all of these will say solve because they are equations. So I have 1 minus 5x equals negative 6 over x squared. My least common denominator is x squared, so I'm going to multiply both sides of the equation by x squared. So I have x squared times 1 minus 5x equals x squared times negative 6 over x squared. When I do this, I'm going to use that distributive property, so x squared times 1 gives me x squared times a negative 5x here, and then this will give me negative 6x squared over x squared. Well, here the x squared stays that way. Here, x squared divided by x leaves me with just 1x, so I'm left with minus 5x here. And here, the x squareds will cancel that, so I'm left with negative 6. Notice when I multiplied by the least common denominator, I got rid of the fractions. Well, now I notice that this is a quadratic, and the way that I solve a quadratic is I set the equation equal to 0. So I set my equation equal to 0, then I factor this factor to x minus 3 times x minus 2 is equal to 0. I use my zero product property, and I set x minus 3 equal to 0. And I set x minus 2 equal to 0. Then I solve for those, and I get x equals 3 or x equals 2. Both of these are solutions, so you would substitute those back in to check your answer. Okay, here we have another example. I have x over x minus 3 plus 3 halves equals 3 over x minus 3. So my least common denominator is 2 times x minus 3. So I multiply both sides of the equation by 2 times x minus 3. And when I do that and I use the distributive property, that's the same thing as multiplying each piece times 2 times x minus 3. So I have 2 times x minus 3 times x over x minus 3 plus 2 times x minus 3 over 3 halves is equal to 2 times x minus 3 times 3 over x minus 3. And when I do that, here the x minus 3's cancel out, and I'm left with a 2 times x. Here the 2's cancel out, so I'm left with a 3 times x minus 3. And here the x minus 3's cancel out, so I'm left with 2 times 3. So here I will go ahead and use my distributive property, and I get 3x minus 9. Here 2 times 3 is 6. This is a linear equation because it just has x's, so I will get all the x's on one side, and when I do, I get x minus 3. Now I look very carefully because I noticed if I went back and actually stuck a 3 inside here, 3 minus 3 gives me 0, and I cannot have 0 for my denominator. So what I notice is actually there is no solution to this problem. Even though I did all this lovely